All right, welcome back to Mr. P Helps with Geometry. This is Unit 1, Topic 1, Lesson number 9, Day number 9. So first starting off with, today we're going to be doing parallel lines, and we're going to start off with a warm-up where we're going to be copying a segment. And with segment addition, which is what we did in the very last video. So the very first one, I'm going to measure segment AB, and then I'm going to make a copy of it and call it CD on the line provided. So there is my measurement of AB. I come over here, put my fixed point on C, do the exact same size copy, and that point of intersection is going to be my point D. All right, so now segment CD is the same as segment AB. Now, for the second question, it's a little bit different. Now it says copy EF twice. So I'm going to put my fixed point on E. I'm going to measure EF first. And then I'm going to copy it twice so that segment GI is twice the size of segment EF. So there's once. And then I do it again, and that's twice, and there we go. So now we have the distance from G to L. So L is over here, and L is twice the distance of EF. All right, so now we're going to be doing parallel lines. So just showing a couple of examples of this, not going to be doing all of them. So when you're doing parallel lines, the first thing you're going to do is choose a point, any point along the given line. Now, by the time I'm done, I should have a parallel line that's like this. That's the answer I'm looking for, but that would be just a guess. So I need to be precise and prove that the line is going to be the same. It's going to be exactly parallel to the given line. So it's really copy an angle, to be honest. So what I'm going to do is I'm going to first pick a point on the line that they gave me. I'm going to connect that point, but going past it. Usually you want to go about twice as far past it. And then I'm going to copy an angle. If I can make this angle the same size as this angle, then what we would have is corresponding angles, and that would prove that the two lines are parallel. So the next thing I'm going to do is I'm going to use my use my point of intersection, put my fixed point on that, put my pencil on the other point of intersection, and make a little arc. Slide it up to my copy and do the exact same thing. And now what that essentially does is that this point is basically a copy right here. So then I can connect that to point P going in both directions, and we will have ourselves a parallel line. So going this way, and I'm going to go backwards using my straight edge to connect that way. And then what we have is parallel lines. So I'm going to use my notation, put arrows in the middle of the line, and there we go. So we've got two parallel lines. Now, I'm going to go to the next page because what we have here essentially is this is the same question. The only difference is that we have 2 points put on the line for us. You don't have to use those points. They're just there. If you want to use them, you can. So I'm going to connect A to P first. Now, if you could do the same thing from B to P, you would just be making your angles on the left. I chose a point to the left side of P, which means I'm going to be making my angles on the right. And now I go through the exact same steps. Putting my fixed point on A, I make an arc. I come up here out of P, because that's where I want my parallel line to be. I make the exact same arc, and then I measure from intersection to intersection. Now, I once again remind you, you could have done these exact same steps from point B, and you would just be ignoring point A, just like I'm ignoring point B right now. Point B is not useful to me right now. So now I'm going to make this point of intersection, and then I have the point I need to make my parallel lines going in opposite directions like such. All right, so then this line is now parallel to this one, and it's going through point P. All right, so I'm going to go ahead and look at the next one as well. So if you look at the next page, on page 41, once again, it's the exact same direction. It says construct a line parallel to FE, but going through point R. I once again remind you that you don't need to use these points E and F. I'm going to use a point over here. I'm going to make my own point on the right side of the line, and I'm going to use it instead. Now, I prefer to make the angles on the right side, but this time I'm going to be making the angles on the left because I chose a point that's on the right side of point R. All right, so I come over here to point R. I'm going to make the exact same arc from it. And what I want to now do is find that second point of intersection. So I'm going to measure intersection to intersection like I did on the last two examples. I will make a mark there, so proving that I measured it. And then come over here, make the exact same mark, and now I know where point R needs to be connected to. So connect here to here, and the same thing going backwards. And you've got yourself some parallel lines, parallel to segment EF or line EF, but also going through point R. And that looks like that was it. So pretty quick to show that one construction, and I will see you on the next video. Have a wonderful day.